Hi, everyone. Welcome to AI Essentials, Prompt Engineering and Use Cases in Financial Services, presented by Forvis Mazars. I'm Jared Foreman. I am the managing partner for our enterprise risk management and quantitative consulting practice here at Forvis Mazars. Just to refresh everybody on who Forvis Mazars is, so we are a top 10 global professional services firm. We've got about 40,000 people across the globe. We operate in over 100 countries. And while we support all industries specific to financial services, we have over $1 billion of annual revenue across audit, tax, and consulting. And we work with banks from the largest of the global systemically important banks to our super regionals here in the US, to middle market, and our community banks. And we're very proud to have many of you joining today as our clients. So we have a fun agenda, and while it seems short, it is jam-packed. So, buckle in. We've got our introduction overview of some of the key concepts related to AI. We'll talk through prompt engineering. We'll go through some of the use cases in financial services, and hopefully we'll leave some time for questions as well. We've been talking to a lot of clients on this topic and advising them. So we've got some really good perspective on where the collective industry really is in terms of deployment, management, and governance of AI, and specifically Gen AI. So this session will be led by some of the key leaders that are talking to all of these clients and doing work with all these clients in this space. And you see them on this slide here. We'll make this accessible to all audiences. We know that maturity varies across our clients and different institutions. But the key thing is you are here to learn and potentially pick up some last minute CPE before year end. But that's always the first step in the process. So without any more ado, I'll turn it to the team to talk about the complexities on what, in my opinion, will transform the way that we do business on a very, very grand scale. So Andreas, why don't you take it away from here?
Thank you, Jared. Hi, everyone. Thanks for joining. So to start with this discussion, we're going to go into some key concepts of AI. What does it mean? How some definitions might differ from institution to institution. So it makes sense for us to first explain the general terms of what we're going to talk about to make sure we're all aligned and understand the same thing. But before this, let's talk about why AI is dangerous as well. And with a quick Google search, you might be able to find hundreds of cases where institutions recently, because of the surge of Gen AI, the surge of ChatGPT, a lot of institutions have had some issues using this. And we picked 4 just to emphasize the risk associated with using AI with your institution without any sort of framework that can protect your institution. So the first one is about Air Canada using a chatbot, and you'll see that most of those reputational risks are associated to the use of chatbots. Air Canada used a chatbot that gave incorrect information to travelers and and the airline argued that the chatbot was actually responsible for its own actions, as if it was a separate legal entity. And this was rejected in a tribunal, and the airline ended up being held liable for the chatbot giving the bad advice to the passengers. We had the DPD parcel delivery firm that had to disable all of its online support for a while because the chatbot was swearing at customers. Obviously, this can create a high reputational risk. In New York, quite recently, a lawyer submitted a 10-page brief that cited 6 relevant court decisions or what it thought was relevant court decisions to its own case, such as Martinez versus Delta Airlines, Zickerman versus Korean Airlines. But the judge found out that all of these court decisions were actually hallucinations from ChatGPT, and the lawyer ended up losing the case specifically because of this decision. There was another case of a car dealership in Watsonville where the car dealership decided to use a chatbot for its website, and a person was able to get a chatbot as a prank to agree to sell a 2024 Chevy for $1 and get the chatbot to say it was a legally binding offer. This was obviously a prank, but so the car dealership did not have to accept the final offer. but this made the news, and this puts the firm institution in the news for not the reason it wanted to. So just to emphasize that there's a few governance failures sometimes that when just implementing AI tools just for the sake of implementing AI tools. And we'll talk about this and we'll talk about use cases later on. But before anything, we just want to emphasize the risk of implementing AI tools without the proper governance framework and risk management framework around it. So I've already, I've already talked a little bit about some AI components, but AI is not actually something very recent. Recently, there's been a surge, especially in the context of Gen AI, and we'll see what this means in a minute. But actually, the concept of having machines do human work started long ago, before the Second World War in 1936. You may have seen the movie Enigma with Alan, the story about Alan Turing code-breaking Enigma, which was the first case of a machine doing some work that a human was not able to. And this led to what we call the Turing test, trying to see if a human can be deceived into thinking they're speaking to another human when they're speaking to a machine. And actually, in 1956, this is when, in Dartmouth, the first use of artificial intelligence, the term artificial intelligence was used. The first chatbot, Elisa, was actually published in 1966, and was in the first start of natural language processing, NLP. In the 80s, we had the start of expert systems, where the humans started using intelligent systems for specific expert tasks. But when everything really started to boom was in the late 90s, when those expert systems started beating masters at their own game, so to say. So we had IBM's Deep Blue beat Kasparov in chess, and that was a massive breakthrough in the world of machines and AI. In the early 2010, machine learning itself, we'll see what this means in a minute, made huge strides and advancements. And in 2012, there's what we call the deep learning revolution. BERT and GPT, you already have heard of GPT or ChatGPT from OpenAI. Google released BERT in 2016. That was the first version of those chatbots, which are much improved nowadays. In 2020, OpenAI released GPT-3, which is the one that became more famous due to its advancements. And since the 20s, so since 2020 and more recently 2023, prompt engineering became one of the forefront to get the chatbots to exactly do what you want. GPT-4 came out, pushing generative AI and prompt engineering really to new heights. So I've talked about prompt engineering, I've talked about GPTs, NLPs, deep learning, machine learning, but what do these mean exactly? We've made a little diagram here where we try to define a few terms that you will hear in the world of AI, and we'll go a bit deeper in some of those terms. But to begin with, what do you mean by artificial intelligence? So when we talk about artificial intelligence, we're talking about systems or machines that mimic human intelligence to perform tasks. So when we decide to use the term artificial intelligence, we're talking also about a system that learns and adapts from its experience. So there's a broad set of techniques, from rule-based algorithms to complex learning systems like supervised and unsupervised learning. And the aim of this is to perform tasks autonomously or semi-autonomously. And this differs from what you may have heard of RPA, robotic process automation, where there's no learning involved. And this is the key component of artificial intelligence, learning. So there's two types of learning. There's the symbolic learning. We won't go into too much detail because it's a bit old school. It's an early approach to AI where there was a use of explicit rules and logic to represent knowledge and perform reasoning. But what's really interesting and used massively in the current world is machine learning. So machine learning focuses on pattern recognition and is completely data-driven. You've probably heard the fact that using artificial intelligence is It's done by data scientists, usually developed by data scientists. It's heavily data oriented. This is a machine learning component. And this involves using algorithms to enable computers to learn from patterns. And learning from patterns there's three different ways to do this. There's the supervised learning. Supervised means that we're using labeled data. And by labeled data, I mean, we feed the computer, for example, pictures of cats and dogs with a label below it. We say this is a cat, this is a dog. We feed the computer hundreds or thousands of pictures. So this is the input data. And by the end of that training phase, label training phase, when we feed the computer a new type of picture and ask the computer what is it, a cat or a dog, it will be able to tell us what kind of animal we're looking at. So this is, in simple terms, what's supervised learning. The key thing to remember here is the use of labeled data. Unsupervised learning, this is where the algorithms analyzes data without any pre-labeled outcome. So it discovers patterns or groupings on its own without any human trying to inform the algorithm the type of patterns it's looking for. This is really interesting, usually also in the context of grouping, for example, similar customers for marketing based on behavior patterns. Here we say that the learning is actually exploratory. We aim for the algorithm to identify patterns that us as, I want to say, limited humans would not be able to see. And finally, there's reinforcement learning that we'll talk about here. Here we create a model that receives feedback through rewards or penalties. Essentially, we create an optimization function, like a maximization or minimization function. And it's a bit of a carrot and the stick, but to the computer. We use a training data set, and if we feel that the computer is doing something good, we give points to the computer that it has to maximize points. But if we feel there's like negative or there's an error, we use the stick, we reduce those points. And this is really a trial and error approach in simple terms. So under machine learning, there's two types of learnings that are usually talked about: statistical learning and deep learning. Statistical learning often is also more traditional learning. So in statistical learning, you'll have algorithms like regressions and decision trees. So those are usually more straightforward models, and those are often used in data analysis, where it's the explainability of those models are usually usually a lot better. Deep learning, and this is where Gen AI comes into play, it's a more complex subset of machine learning. And usually we define deep learning as the use of neural networks with multiple layers to analyze a very large amount of data and perform more sophisticated tasks. So here we call it deep learning and neural networks, mainly because it was inspired by the human brain, and it uses what we call a layer of neurons for advanced pattern recognition. Neurons are simply, you can think of a huge decision tree, and going step by step through that decision tree, but it's so huge that it's not something that we would be able to follow on a simple pen and paper. So on the deep learning, we have three types of subsets that we will be talking about here. The first one is the natural language processing. I mentioned this in the timeline, NLP. So those are advanced techniques for understanding language. So this, you probably have heard of Alexa or Chromecast, or you have Siri on your phone, voice assistants, but also text recognition. If you submit a text and it understands the text, and this would be considered as NLP, natural language processing. You have, I mentioned neural networks, and you also have Gen AI. So what does Gen AI or generative AI mean? Here, when we talk about Gen AI, we mean a tool that generates new content, text, images, music. Recently, ChatGPT or OpenAI published Sora to create videos. And you can mix Gen AI with NLPs so that a new text, a new image, a new music is created by analyzing some text through NLP. So those are a few key concepts. And having laid out the definitions, and having talked about the governance failures and the reputational risks, you may ask, okay, that's great, but given the risks, why should we implement AI in our institution? And there's three main reasons to do this. So despite the challenges and the risks and the need for risk management, governance, data scientists, there is a minimum requirement at the moment that we see our different clients looking for. It's to keep a competitive maintenance. If all your competitors are implementing some sort of simple tools to improve their efficiency, improve their returns, and with the evolution of AI currently, with those any counterparties that is implementing AI tools to improve efficiency is expected to evolve much faster than those that remain without any AI tools. So essentially, all this to say, the competitive maintenance is the minimum requirements to implement AI tools to keep parity with peers. But there's also those clients that are those organizations that aim to gain a competitive advantage. They go a bit the next step, embed AI in existing processes, maybe get some sort of data scientist involvement to create AI specific to the tools within the institution. And finally, you have the competitive breakaway. Those are the few institutions that have venture capital specifically for the development of in-house AI. We're thinking here of AlphaZero, ChatGPT, and tools like this. Most of the organizations we've been discussing AI with fall under the 1 and the 2, competitive maintenance and competitive advantage, because this is where we are right now in terms of the evolution of AI within institutions. Now, maybe it's a question for you. Where are you? Where do you think, and it's food for thought as well, although we might have a question coming up in a second for the CPEs, but where are you in your technology maturity? Are you at the paper and pencil Excel phase? There's no right and wrong answer. Are you in the RPA phase where you know your institution has implemented automation tools? Are you at the phase of implementing AI, but with low code or no code? There might be some sub-phases in between. Or are you at the phase where your institution has developed machine learning algorithms, Gen AI tools, and implemented them for its clients? So this will launch the first polling question. Okay, interesting. So we have 18.3% that have already implemented AI tools, 25.9% low code, 28% RPA, 27.8% paper and pen. That's very interesting. It's very well distributed, and it shows that different institutions are at different maturity level. Some institutions are less risky, want to implement a full governance approach first, while some are more already implementing AI tools. So yeah, very interesting results here. So some final key concepts before I turn it over to Zohar. You might hear about build versus run. So what does build, what does run mean? Build, very simply, is the whole process of developing a tool that will then be used by users. So a build has to be built through the express needs of business owners. And this is very important. We want to emphasize this. The data scientists can collect the data, they can create the models, but if there's no need for this, it's going to cost a lot of money, time, that may not be required at the institution. So we emphasize the need of a build for your institution stems from the need of a business owner. Data scientist then chooses an algorithm and data set, trains the algorithm through this data set, which creates a tool. This tool is then transferred to business, where a new data is inputted by the owner. For example, in the case of a chatbot, we have a prompt that's created by the owner, the business owner, but it can also be in case of machine learning algorithms, additional data for forecasting, for example, and the tool is executed and the results are obtained by the business owners. Build versus run. The use of ChatGPT, for us, we're only on the run phase where we input a prompt, whereas the build has already been done by the data scientists at OpenAI. Now, finally, when we talk about GenAI, there's three types of GenAIs that are often discussed in the marketplace. There's the first one, the pre-trained GenAI. This one, you might think of, ChatGPT, for example, Llama, Gemini. Those are pre-trained on very large data sets and have acquired knowledge before we use it, us as consumers. It's been externally built from, so this is the build. It was external, and the run is what we're doing. Then the second one is fine-tuning of GenAI. And this is one of the interesting components where you continue to train a pre-trained GenAI to improve performance on a specific topic or a specific task. So for example, you can train ChatGPT, for example, to be your law expert or a CPA expert. And this you can either include new training data within and give it a higher weight in the training of the algorithm, or you can also do this through prompting and fine-tuning by providing questions with labeled responses. This is a good answer, this is a bad answer. Zohar will talk about this a bit more in the prompt engineering section. And finally, there's RAG, retrieval augmented generation. There's a few technical terms here, but RAG is being used more and more by institutions to get key GenAI implemented in their own systems. So the first term that you might hear about is embedding. So embedding is very simply, it's a way to represent words or pieces of information as numbers or vectors so that the computer understands and works with them. It'll be easier for the computer to understand, to transform a sentence into a single vector or multiple vectors, because it will not have to recognize the words, but instead work with those numbers. You have a retrieval system. So the retrieval system uses this embedded prompt, so the prompt that has been turned into numbers or vectors, to do a search in a knowledge base, so basically a digital library. And based on this vector, it identifies chunks in this library, so other numbers and other vectors that contain small pieces of information. And basically this chunk breaks down very large documents. If you submit a PDF to the algorithm, and we'll be able to retrieve the right information from this large document into manageable part for the computer. This allows the AI, unlike, for example, ChatGPT, to be able to analyze hundreds of pages of PDF and return an appropriate answer. And based on this, basically the AI is able to understand the user's question better and provide a more accurate response. Essentially, we create context through the prompts and the chunks of this knowledge base. So it's essentially basically asking a question and getting an answer that includes all the important details that you want from a specific digital library. So now that we've presented the key concepts, I'll turn it over to Zohar to talk about how to get those answers that you want from the chatbots.
Thanks so much, Andreas. All right, so we are going to now dive into the world of prompt engineering. And prompt engineering is really a crucial aspect of working with AI and machine learning models, especially Gen AI models like GPT-4 or Copilot. And this is really the method you're going to use to obtain the results you want from the model. So it involves designing and refining your prompts to guide the models into generating specific, accurate, and really relevant outputs. And these effective prompts can significantly enhance the performance of the models and make them more useful for your applications. So today we'll go into that and explore why mastering the skill is really crucial for using AI and how it can significantly advance your own operations. And to link it back and also to remind you of what Andreas was just mentioning, fine-tuning can be done through prompt engineering as a way to train data. So Each prompting method has its own unique advantages, whether you want to give specific restrictions, leave it open-ended, or provide an idea. There's really no right or wrong way. The key to for you is to find your own optimized method based on what you want to achieve. So we're going to go through a lot of those examples now, but remember that really the value is going to come from you continuing to test this and practice this at home. And by experimenting with various prompting methods, you can really discover what works best for your needs. So we'll begin by going through some key concepts and prompting types. The first being zero-shot prompting. And this involves asking the model to complete a task without providing it any prior examples. It's useful for really straightforward tasks where concepts or examples aren't required. For instance, you might want to ask the model to list 3 benefits of AI in finance. This is what a lot of people are going to start off doing when using AI. I know I did early on, and then I would get somewhat frustrated that the results might be too long, too short, didn't have the type of information I was looking for, etc. And there is a time or a place for this, but more often than not, you're going to want to remember some of the following concepts to really refine your results in what you're receiving back. So for example, few-shot prompting. Here, you're going to supply the model with a few examples to better specify the format or the style for generating a response. This is best for complex tasks where you want a consistent format or where examples might improve the accuracy. So an example here, providing 2 or 3 summaries of financial reports and then asking for another in a similar format. The next one here, chain of thought prompting. This method is going to encourage the model to really think through its responses and show those intermediate steps, leading to a more accurate answer. So it's effective for tasks that involve reasoning, multi-step solutions, or structured analysis, like complex problem solving or analysis tasks. An example here would be asking, what are the key trends in this report? Break it down in sections before concluding. Role-based prompting, this is the one I use most often. It really involves instructing the model to respond from a particular perspective or a role. And it's useful for tailoring the response in a professional context, especially for tasks that require expertise or a specific tone. So for example, you might ask the model to respond as a financial analyst providing insights on an investment report. On the other hand, you can tell it to respond like a 6-year-old and really break down an explanation to a toddler or something like that. Instruction-based prompting, this one is giving explicit instructions on how to structure the response. It's used for ensuring clear and structured output, particularly in a formal or constrained environment like business reports. For instance, you might ask the model to list the top 3 risks in a report and explain each one of them in 1 sentence. Iterative prompting, you probably do this without even realizing it, but this involves refining the prompt progressively based off of the model's output. So you're going to enhance the response quality over multiple attempts here. And this is helpful for complex queries where initial prompts may not quite yield the desired level of accuracy that you want. And by adjusting your prompt and adding specificity along the way, you're going to keep on going until you meet your expectations. Contextual prompting involves adding relevant background information to the prompt, and this will improve the relevance of the output. It's really useful for situations where responses within specific knowledge areas or recent developments are needed. For example, you might summarize a report's impact based on recent trends in asset management. And the last one we have here, constraint-based prompting. This involves setting limitations or conditions within the prompt, like word count or focus area, and this can ensure your responses meet more specific formatting or content requirements, particularly for concise summaries or tailored outputs. For instance, explaining a concept in under 50 words that focuses just on financial risks. All of these are really great methods, and we will talk through examples of each one soon. But I do want you to just keep in mind that you can mix and match methodologies for prompting Like contextual prompting doesn't mean you can't also do constraint-based prompting. With that example, you can both add context to your prompt and have the AI limit your answers to 3 lines each using specific and certain information. All right, so before jumping into the examples, I want to discuss the possibility of wrong answers. And here, sometimes Copilot isn't always going to be right. But that's why you need to verify what it is drafting for you. Just like in our own today business operations, with teams that we manage or groups that we work with, a first draft isn't always going to hit the mark of what you're expecting. You're going to have to refine instruction, add context, and along the way, you might get some inspiration and ultimately get to that winning draft or idea as you go on. In the realm of Gen AI, it's important to recognize that even when a model produces results that aren't entirely accurate, these wrong outputs can still be extremely valuable. And this concept is often referred to as usefully wrong, where it's highlighting how unexpected or incorrect responses could really spark creativity and lead to innovative ideas. For instance, when AI generates a response that deviates from your expected answer, it can prompt a user to really think outside the box and explore new perspectives they might have not considered otherwise. This discovery can be particularly beneficial in fields that thrive on creativity and innovation, like marketing, design, or content creation. And usefully wrong outputs can also really serve as a starting point for your refinement and iteration. In the process of prompt engineering, an initial incorrect response can highlight areas where the prompt really needs to be adjusted or clarified. And these wrong results can also help identify gaps in the AI model's training data or understanding. So when you get an unexpected or incorrect response, it can really reveal areas of weakness where the model lacks sufficient knowledge or has been trained on biased or incomplete data. And that type of insight can be really invaluable for developers as it's providing the direction for that further training and improvement in the model. By addressing gaps like this, the AI will become more robust, more reliable, and ultimately enhance the overall performance and utility. And the last thing I'll say on this is the concept of usefully wrong really underscores the collaborative nature of working with AI. So rather than viewing AI as this genius, perfect visionary, users should really approach it as a creative partner that's offering you suggestions or ideas. Some of those might be unconventional and unexpected, but that collaborative dynamic really encourages you to think more deeply on the AI's outputs, critique them, evaluate them, and then use them as a springboard for further exploration and innovation. So in this way, these incorrect results can really still contribute to a richer and more dynamic creative process, ultimately leading to more innovative and impactful outcomes. All right, so with that spiel being said, let's take a look at some examples of the prompting methods and the outputs. The first one here that we discussed, zero-shot prompting. We asked the model to summarize the latest quarterly financial report for Microsoft. And you can see that Copilot in this instance produced some highlights of a related press release in an amount of detail that it deemed appropriate. Moving on to few-shot prompting, we gave a couple examples here of the type of summary that we're looking for. And you can see now that Copilot actually produced a similar sentence with the latest information from the applicable quarter using the same source. Now you see a lot more text here. With chain of thought prompting, we asked Copilot to summarize the latest quarterly financial report, but explain step-by-step how it reached the conclusions it did. So this is a lengthier answer, but really helpful in fact-checking. And you can understand here how Copilot is deducing each point, and you can make sure you agree with the methodology as you look through the answer. Role-based prompting, we here told Copilot that they are a financial analyst. And here you can see that a really different type of tone and facts were given in the answer, aligned with what a financial analyst would typically provide or speak to. This is really helpful in setting the scene for the type of information you're looking for. Instruction-based prompting, you can see we asked Copilot to limit its answer to 3 sentences and cover exactly the key points that we were looking for. This type of prompting is really helpful when you're looking for a quick and concise answer. Contextual prompting, we added relevant background information here. So we asked it to focus on the context of an acquisition. And we can see here that the answer given was really tailored to this context, and that Copilot actually pulled in information that wasn't given in any of the prior prompts. All right, and the last one, we have constraint-based example. Similarly to instruction-based, it's showing a concise answer based on our direction. So again, this is really helpful when looking for a quick and concise answer. As evidenced in these examples, you see there are so many ways to get to a similar answer with prompting. And again, to reiterate, there is not a right or wrong approach, but really being mindful of how you're asking these questions and gearing them towards the output you're looking for is going to lead towards your most effective approach to using Gen AI. Okay, and we have our second polling question now, asking, do you ever use AI chatbots? So A, never, B, only for personal projects and questions, C, only for work, and D, for personal projects and for work. So we'll give everyone a few seconds to answer this. Anyone that may have tuned out, go back in, find the polling question to make sure you are getting your CPs. All right, so we have our answers. There is actually a quarter view that said never. The majority only for personal projects and questions, and some for work and for personal projects and for work. And hopefully after this section, you'll be able to use it more and more effectively. So now let's talk about some frameworks that can really help you remember how to create these effective prompts and use the methods we just talked about. The first one here being the TRACE framework, and this stands for task, request, action, context, and example. And what this is meant to do is help in outlining the key components of a prompt. So for this example, you might want your prompt to show the key components of a policy and the responsibilities of an employee in protecting trade secrets. Rather than thinking through all of the different methods we talked about before, you can use this TRACE acronym and put together the components for a compounded prompt of, I need guidance on how to protect company ABC. Outline the key components of the policy and the responsibilities of an employee in protecting trade secrets, provide a detailed explanation of the steps that should be taken to ensure compliance. For example, show the process for properly labeling and handling confidential and proprietary information. That is a mouthful to say and to type out, but if you think of those components, the task, the request, the action, the context, and the example, it's easy to have that framework and really put it together. Similarly, the STAR framework stands for situation, task, action, and result, and this should also help you in structuring your prompts. For example, here you might want to develop a detailed plan on how to enhance team productivity and effectiveness. Similarly to that TRACE example, you can put these pieces together for a compounded prompt. Two more of these, TAG and RTF. TAG stands for task, action, and goal. RTF stands for role, task, and format. These frameworks will also help you in creating prompts that are clear and structured. And in these examples, we're creating a plan of action to get a project back on track. One more of these, CLEAR. This stands for concise, logical, engaging, actionable, and responsible. It is going to help you in crafting prompts that are both clear and engaging. For example, here we wanted to explain why the agile methodology is in a straightforward manner and provide real life examples. I won't go through reading all of these, but good for you to remember and help really bring those different methodologies together. And just in case those were not enough frameworks for you to remember, we have one last fun one to share called the golden prompt. And this method really uses a structured and iterative process to create effective prompts for AI models like ChatGPT or for Copilot. And what it does is refine the prompt by generating content, critiquing it, and then asking questions to ensure that it meets the user's needs and communication styles. So you can see a very large chain of text here. You should keep that and copy and paste it. A lot of brownie points if anyone can actually memorize that. But essentially what it's doing is asking the AI to help you create a prompt. So before starting the chat with a chat box, you would open a separate chat to define your prompt. In that chat, paste in this golden prompt, and then the chatbot is going to ask you what topic do you want to talk about, and that's the first information you would provide it. The AI would then give you an initial prompt with some pros and cons and advice on how to improve it, and then ask you 3 questions on enhancing your prompt. At that point, you can choose to either answer those questions or take the prompt as is. And answering the questions can be considered as creating more instructions, context, and constraints, those concepts we talked about earlier. And you can continue to do this iteratively, and the AI will really help you improve the prompt as you go. Or you can choose to stop wherever you want, and then deem that your prompt is optimized enough for your purpose. So here we're just going to see the output of that. You can see the prompt related to regulatory requirements in finance and accounting. In turn, we got suggestions to critique here, have questions on how to improve the prompt until we ultimately get to where we want to be for our effective prompt. So those were a lot of examples and methods to digest. And we'll wrap up the prompt engineering section, but just to recap some of those key points we discussed today, prompt engineering is really a powerful tool to use to enhance the performance of AI models. We really recommend to use a combination of these techniques and put them together to really optimize your own prompting style. There's no right or wrong there, but just getting to the place you want to be. And as a cautionary reminder, really check the output of these prompts. You don't want to be those lawyers in court that are using AI hallucination information to a judge. So just make sure you're looking there, you're checking there, and you're making sure that the output there is appropriate. And with that being said, I will hand it back over to Darian, and she is going to talk through some real world examples.
Thank you, Zohar. Appreciate that. We actually have our 3rd polling question, so please pay attention. What we have here on the screen for you guys to answer within a minute is, does your institution have a framework to identify AI use cases to implement? So you have a couple of options. Option A is, yes, you do have more of a formal process. Option B, you have a process, but it's informal. Or C, you do not have a framework to identify AI use cases at this time. So we're just going to start with this polling question before we get into real world examples, and we'll give you the full minute, but I do want to remind you, you guys are doing a great job of asking questions through our chat. If we do not have time to get to your question and provide an answer during this session, we will be following up with everyone in the new year to answer any questions that go unanswered today. So just wanted to mention that if you feel like we haven't had a chance to get through or get to you, we have a lot of information to get through. So, okay, this is a pretty good split. No, 49% of you may really appreciate the next section because you may change your mind afterwards. So we are actually going to get right into it and talk through some real world examples. Before we get into those specifics, I do want to talk the specific examples. I do want to talk first about important considerations when evaluating AI use cases. And I did also want to share, just to bring back all of the information that Zohar just shared in a very quick time frame. I actually just used prompt engineering the other day when I asked, and I used role-based prompting to give you an example, when I asked Copilot to act as a 4th grade teacher and develop practice problems on mean, median, mode, and range for my 10-year-old. And then I refined it a little, and I just added this when I was listening to Zohar's presentation. I refined it a little to use instruction-based prompting, so I was very proud of myself, and it was pretty cool. So let's talk through the AI pilot process. So it's something that's going to take time, just like with anything else, to go from idea to implementation. It's something that It's important throughout this whole process and everything that you see on the screen to maintain strong risk and governance controls, along with sound project management practices. That's what's on the left side. But when thinking about the AI pilot process and how to step through an idea, it's critical to identify organizational goals when it comes to AI, and that will help you identify relevant use cases and which specific use case is a good candidate for a pilot. It's important to identify relevant stakeholders, define required data inputs and security standards, then develop a plan to socialize the pilot process, complete with any relevant education. And it will be important to engage all lines of defense with model risk management in the second line, audit in the third line, and even regulators. And documentation will be critical, as you can imagine. You will want to make sure your efforts, plans, and results are very well documented. You will need to identify test cases for the pilot and define key performance indicators, then develop your specific AI use case, review results, iterate as needed, establish an ongoing compliance controls, and data standards. It may be a long journey, especially if you're newer to the world of AI, but as with anything else, policies and procedures will be critical. And you will want to socialize and integrate the new AI product or tool into the broader organization, and then move to the next use case, and so on. So now that we got you thinking about the AI pilot process, what should you consider when evaluating potential AI use cases? You will want to start with or consider an impact and feasibility assessment. So when considering impact, which is on the left side of your screen, it is important to look at business value, such as how the AI solution aligns with your business objectives and how it will impact your organization, such as cost savings or enhanced operational efficiency, if that applies. It will also be important to consider scalability. So what are the long-term benefits versus short-term gains? As with all AI, social and ethical considerations are critical. What impact will the AI solution have on employees and their job roles? What about ethical implications around bias and fairness? And how does the AI solution comply with regulations? Another consideration is how will the AI solution impact market differentiation? How will your organization benefit? So with respect to feasibility, which is along the bottom of your screen on the x-axis, how feasible is it technically? Is the data available, and what is the quality of the data? How compatible is the AI solution with existing systems, and how much technical expertise is required? Along the same lines as technical expertise required, what about budget constraints for staffing and the availability of the right skill sets in your organization? What is the time frame for development and deployment? When it comes to risk management, you will need to identify potential risks and mitigation strategies and consider contingency plans. And proof of concept will be important when considering feasibility. You will need to be able to explain the proof of concept and have metrics and analysis to substantiate your plan. So when you look at the chart on the screen, your first priority use cases are those in the top right quadrant, since they have the highest value, whereas low impact and low feasibility use cases are not something that you may want to prioritize in the beginning. Okay, let's talk about use case criteria. It's important to ensure your pilot project is both impactful and feasible, like we just discussed. So when thinking about feasibility, it's important to think about regulatory compliance, legal compliance, operational risk, transparency and accountability, and other risk-related considerations. It's also important to think about data privacy, data security, data availability, and data quality. Also, what's your infrastructure like? Is it ready for an AI solution to be deployed and implemented? What resources do you have available? And how complex will deployment and maintenance be? When it comes to impact, you should think about costs, increased revenue expectations, risk exposure, expense reduction, as well as performance and how the use case may increase productivity and save time, but also how reliable is it and what does scalability look like? I mentioned that just a minute ago. So before we move on, I want to quickly highlight some common pitfalls that organizations should be aware of in hopes of avoiding setbacks. Not having clear objectives or having undefined goals can be problematic. And so it is very important to make your expectations and your plan very realistic and clear. Data is critical, as we all know, but poor data quality and data scarcity can cause issues. there may be technical challenges or integration issues, and it's important to understand the complexity of the project. If you're not already thinking about this hand in hand with AI, you really need to be thinking about ethical and social implications, because ignoring bias and fairness, for example, or privacy concerns can be detrimental. So not having, another thing to think about is not having adequate buy-in from stakeholders can present issues, and poor communication can cause major setbacks. So it's important to communicate the benefits and progress of an AI project to prevent misunderstanding or issues with trust. And if you don't think about scalability and maintenance challenges, you may be set up for issues in the future. It's critical to think about how the AI solution will scale. I've mentioned that a couple times. Failing to identify potential risks early on can lead to unplanned challenges, and not having adequate contingency plans can make it hard to address issues as they arise. And AI can be powerful. It's important not to neglect the human element. Focusing too much on technology rather than the actual business problem that prompted the AI use case in the first place can lead to misalignment long term. All right, let's take a look here now at user task risk exposure. So just as you look at this chart with all the dots, I just want to explain a couple things. It's important to evaluate potential risks and how they're going to be mitigated. That's also very important. When thinking about risk levels, low risk low risk is usually tied with having minimal impact on users and having a low potential for harm, whereas high risk use cases can have significant impact on users and high potential for harm. This all makes sense. Simple tasks are certainly more straightforward, and their outcomes can be more well-defined. Lower complexity often correlates with lower risk, where complex tasks can involve, the more complex tasks can involve multiple variables, uncertain outcomes, and require advanced decision-making that can increase that risk exposure. So you need to consider the user as well. Tasks that directly affect the user, such as financial advice, for instance, that requires very strong risk management. Tasks that indirectly impact users, such as like back-end data processing, may have lower immediate concerns, and you can see that in the chart. So it's important when you're looking at this chart to think about mitigation strategies and the importance of identifying risk, analyzing the likelihood and impact of each risk, what strategies you would put in place to mitigate the identified risk, such as testing and continuous monitoring, and how important it will be to involve multiple stakeholders in the risk assessment process. So let's take a look at a couple real-life examples. These are examples that our data team has worked on, and we're very excited to have multiple different industries represented in today's webinar. So we have some diverse examples to share, and I'm going to run through these very quickly. But the situation here on this slide related to real estate relates to timesheets and the investment of 2 full-time employees that have to work each month to transcribe image data into Excel. So you can imagine that's very cumbersome. To increase efficiencies, a custom web application was created to ingest timesheet data, and it used AI to identify inconsistencies or missing data, which led to improved processes and drastically reduced the time required for this exercise. Here we have an automotive distribution example, where in this case, the client wanted to enhance the auditing process for marketing incentives across the dealership network in order to optimize allocation and reduce errors in bonus distribution. So a web application that leverages AI was developed, and that solution was used to centralize the relevant data and automate anomaly detection through complex control rules and unsupervised learning models. And those were used to identify potential fraud in high-risk dealerships. This ultimately provided a centralized platform that improved traceability and facilitated a transition to a zero paper environment, which led to enhanced quality and efficiency in the auditing process. I know this example is going to be relevant to many of you. In the retail banking world, we had a US bank that was facing a rise in consumer complaints, and to comply with regulations, the client wanted to enhance the complaint management process. So a natural language processing engine was created to access first and analyze over 2 million complaints. The solution identified key topics, entities, and sentiments, and the end result provided deeper insight into customer complaints streamlined the data management, and enabled proactive risk monitoring. We have two other examples that we can speak to on healthcare, and also, actually that is the last one, related to reimbursement process and reducing out-of-pocket costs for patients. This used a predictive machine learning model that was created to analyze the prescription data and predict real-time reimbursement levels and patient costs. These are real-world examples that our data team has experience with. I did think there was another example on the chemical industry, but I'm actually going to bypass this one due to time. So here, I'm not going to go through these, but we have a sample use case matrix on the next couple of slides, actually, that are use cases that we've identified in the financial services industry. And just to give you an example of everything that's written here, there's examples with data extraction from financial documents, code translation, regulatory chat box, I believe, on the next slide, third-party vendor evaluation, and predictive modeling, false positive reduction in the world of AML and fraud. And there are numerous other use cases to consider. So we have given you a lot to think about. There are countless use case examples out there, and hopefully this got you thinking about implementing AI wherever you are in the journey. We touched on the brief history of AI, key concepts. Zohar talks about prompt engineering, and then we ended with just a use case discussion. We do have one more polling question, and that just rounds out the CPE today. While this is on the screen, and the question here is, whether you expect your institution to implement more AI use cases. So yes, we're thinking about it within a year. Yes, but maybe not within a year. It's a little further down the road. Or your answer could be no. You're not in a position to implement any use cases at this time. So we'll give you the full minute so you get the CPE credit. But I just wanted to thank you for joining us today. We really appreciated your time, and we hope that you were able to learn something from our webinar. Please reach out to any of us with any questions that you have. And we're going to close with a quick video when this polling question is done, just to run through the information you need to know about CPE. You can see the answers here, but I know that we're short on time. Glad to see that many of you are looking to do this within the next year.